Western civilization is moving closer to a point of irreconcilable, unstable equilibrium, as frighteningly increasing numbers of people trust nothing. Media, academia, and especially the governments are no longer held in high esteem. Regaining trust is often impossible after betrayal. However, transparency is essential to any healing process, and that is the essence of the Don Sullivan Show. Please listen to the team explore, probe, and debate cutting-edge science, technology, and computing. Play ball! Hello, everybody, and welcome back to another episode of the Don Sullivan Show, the show that we discuss all things science, technology, and computing, and we do it on the level that is totally consumable by your average American and Western teenage soul, so that everybody in the future generations is going to be able to understand all the science and at least everything that you see in the media and can understand how to move forward with it. Now, I think that there's certain things that we do have to address first, and sometimes I forget about this, but I'm going to do it right now. I'm your host, Don Sullivan, of course. I want to introduce you to my partner, Jersey Steve. Say hello, Steve.
Greetings from beautiful and classy New Jersey.
I also want to say hello to, although I'll let you introduce yourself a little bit more, our guest here today, someone I worked with at great length at VMware for a long time, one of my favorite people on the planet, Miss Gina Rosenthal. Say hello, Gina.
Hey, y'all, from sunny and hot Austin, Texas.
See, we're doing this from all over the place. Last time, we actually had an episode from Denver International Airport. Today, I'm actually in my office basement, which flooded the other day. So if you were actually able to smell it, it probably would be bad. But right now, it's okay because you're only listening. This is only audio. This is only audio. But none of my electronics are hurt, so we're in good shape here in Littleton, Colorado. All right, first, I want to, because this is something that our lawyers insist on, I need to read out the obligatory disclaimer waiver. So all statements by the host and guests on the Don Sullivan Show are the personal opinions of the host and guests, who all agree that the following content is the property of Zetalytics LLC to be used publicly and exclusively on the Don Sullivan Show. Anybody who disagrees, disagree for now or forever hold your peace. But more importantly, it's time to go on to the real discussion. Hi, everybody good? All right. Gina, let's talk about what is referred to as artificial intelligence, which I'll state right now, for the record, believe is, for the most part, branding, a buzzword that as Gina and I evolved in our careers through VMware and through business critical applications and so on, this incredible notion of machine learning and deep learning from an academic and a practical perspective took root. And then they dusted off the concept from 1950s of artificial intelligence and sort of wrapped it around all of this. And then as the various different companies created these unfathomably powerful processors, whether it was NVIDIA, it is NVIDIA, or it's anyone else, that we were able to use these incredibly powerful processors with unfathomable amounts of data on the internet to create a machine learning model, which for the most part uses arithmetic, interpolation, extrapolation to come up with best guesses for everything. And that's what we look at as artificial intelligence. When you really get to legitimate, true neural networks, not just neural network models, that actually results in something that is more of an intuition or a real thinking, then I'll be a little bit less antagonistic, I think. But Gina, I would like to know your angle on this. What do you think? Please tell me in the 2020s, what do you think artificial intelligence is? Am I wrong?
No, but you said a lot. So let me digest some of that really quick. Let me play it back.
I usually do, don't I, Steve?
Yeah. So, no, I agree. Artificial intelligence is a marketing term from the 50s. So this is not, trying to get everybody to join in to talk about the concept of deriving data from machines. And so it's not anything new. Artificial intelligence is kind of the practice in general of doing things that humans would normally do with machines. And when I know back at VMware, until the LLM craze, the large language model craze, took hold a couple of years ago.
So, Gina, let me stop. What is that? Tell us what that is, the large language model.
Well, let me get back to that in a second. I was going to talk
All right.
before I talk to that. Let me talk about
You got it.
we used to have like a chart that had AI at the top, but everything else was the architectures underneath of it, right? So large language models weren't even a thing because they weren't that big of a thing when we were doing this back at VMware, but we talked about deep learning and machine learning and the different architectures those took. And then we talked about high performance computing in general. And all of this kind of rolled up to this umbrella term
Big
of
data.
artificial intelligence and big data, right? So I think what happened was there was a bunch of innovations between the time I left in 2019. So the innovations were happening just as I think I was getting ready to leave. And I remember we had a colleague there who's in product management named Ziv, who was walking us through the things he thought was going to happen, and they did all happen. So we've got the thing he was walking. He's the first person to talk to me about transformers and how the transformers made it possible to use the large language models and do more than just things with words. You could do things with pictures. You could do things with music. You could do a whole bunch of other outputs besides just a resume or something like that, right? So
I don't know if you were there when Pat Gelsinger, the CEO at the time of VMware, referred to artificial intelligence as a 50-year overnight success story. Now,
Yep.
The only thing I disagree with him about was it's really a 70-year overnight success story. And that's when you went off to create your wonderful company, when you're an absolute master blogger about all of this for Digital Sunshine. And I can't be, I'm just sitting here thrilled and beside myself that Digital Sunshine has a presence on the Don Sullivan Show. But go ahead, please.
Me too. I love it. I'm so happy you finally decided to start doing this. This is good. But that's one of the things.
Gina, for our listeners that aren't as tech savvy, can you describe what a transformer is, since it was critical for the large language models to kind of move forward?
Right. I'm not sure that I can go really deep because I'm not very deep. I'm very wide as far as like kind of a analyst view of what things do. So Don, if you want to jump in here and get more technical about it, basically it allowed mixing of different types, I think. I might be wrong about this. Allowed mixing of different types of deep learning activities. So it wasn't just words anymore. Is that right,
Gotcha.
Don?
Yeah, I think that's a very good explanation on this level. And I think that we can actually segue that into the idea of large language models as opposed to small language models. And the way I look at it, see again if you agree with me in this, a large language model is basically just any language on Earth. We don't need programming language anymore. We can just talk to the computers and it can understand exactly what we want to have done, and it does it. And I also look at small language models as being much more precise. So I always said that, well, the computers, they don't speak Jersey. But now they do, because basically a small language model is the equivalent of a dialect to a language. I think there's some relevance to that.
You could absolutely train a language model to be Jersey specific. You can build language models for pretty much anything.
Yeah, you guys know nothing about talking here, and that would understand exactly what I just said.
Exactly.
I don't know, because they don't understand my accent. And when I get mad, my accent comes out more. And my stupid Google lady can't understand what I'm saying, and it pisses me off so bad.
Well, they need to get better. They need to get more precise.
Also, she is very selective about the Spanish words that she knows. And living in Texas, we have a lot of streets with Spanish names. And so if you say them properly, she doesn't get it. Or if you say them the way Austinites say them, which is some of our, like we say Guadalupe for our Guadalupe street instead of Guadalupe. So it's just a whole big thing. And
so the dialects aren't all comprehensive yet. But as I said, that's what I think of a small language model.
Well,
and again, I'm oversimplifying.
She should
I'm sure.
Understand me. She pisses me off.
They don't get the Spanglish down that good at the moment. So
no, I don't know about the Spanglish.
I'm sure it's very different in New Jersey with the Spanish in New Jersey coming from Cuba and Puerto Rico and so on. So it's going to be really different there too.
Oh, absolutely.
I don't think I agree with you on the definition.
Well, what do you agree? Tell me. Correct me, please.
Right? So, did you read the paper about the dangers of a large language model? And sometimes they call it the stochastic parrot paper?
No, I did not, or
It's really
I
good.
don't
It's
think it's so.
in the
Please tell
ACM
me.
library. Oh, sorry, I'm talking over you.
No, go. If that's what we're supposed to do here in the Don Sullivan
Oh,
Show.
sorry.
We're
I'm
in
sorry.
a. This is very much like a bar kind of situation where we're all
Okay,
having a
cool.
good time. So please talk over me all you want, Gina. Go for
Awesome.
it.
I love it. I love it. So, it's in the ACM library, but it's a great paper, and it's the paper they got the Google ethics team. They fired their ethics
Woo!
team because
Wow.
they didn't want them talking publicly about there are things we should be wary of about developing these large language models for obvious reasons, even though it was a peer-reviewed paper. So, what was interesting, that paper really kind of clarified my knowledge about what an LLM does. And the stochastic part, that means just repeats whatever you tell it. So, like any kind of AI, putting my quotes up, model, it's the large language models are dependent on the data that they are trained on, right? And so you teach these models to do certain things, and you can tell when you query this with a chatbot or other ways to query the language model, what it's been trained to do. So they're definitely been trained. The large language models have been trained to lots of things with papers. You can get it to write a script. You can get it to code. You can get it to write your English paper. You can get it to create a resume. So that's what it's been trained to do. And the way it does that is it takes it tokenizes the words, breaks them into different pieces, and then it guesses based on the tokens what's the next word going to be based on
Interpolates
how
is a
they
good
were trained,
term, right? That's
right?
It guesses a lot to get the
It
best
guesses a lot,
possible. Yeah, yeah.
and it's not always right. And like the famous example is strawberry. You know that large language models have a hard time telling you how many R's there are in the word strawberry, and it's because of the way that they tokenize the words to be able to figure out what's coming next. So if you ask it how many R's are in strawberry, two all the time, it'll bring you
So
back two
you're breaking it down, tokenized, meaning you're breaking it down into its components
pieces. Yeah,
based on the sound and based on what it assumes is that particular
I don't think it's based on
language.
sound. I think it's based on bytes. So
Well,
because of the
it's
way,
obviously inputting it somehow. So
yeah,
when
the way it breaks it
it's
up, you
taking the
can't figure it
input,
out.
yeah.
Yeah,
So that has to be the diction that's coming in from whoever is.
Yeah.
no, because you
If
can do
it's
it. You can
if
type
you're
it.
speaking or typing, yeah, it's
Yeah,
probably
okay, that's
different.
one way. It's one way. Yeah,
Yeah.
sure.
But so the thing is, what I was trying to get to with all of that is this is all about math, and it's just like you were saying before. It's about complex equations that when I look at them, I remember doing those in college and I hated them. So because it's too much math, I like to write. So I like to read. So
Arithmetic, if you ask me, but go ahead.
that is not arithmetic. That's like some quantitative methods kind of stuff. And it's too much
Lots
for
of
me.
sums, a little bit of integration. It's arithmetic,
Look, man,
but go
I got
ahead.
A's, but I didn't like it. So that's all I can say. But that's all that this is. It's not able to understand us. It's not able to do all these other things. It's actually the transformers, I think, that are helping it understand language inputs from a voice to get to, because think about it. How does it get from a voice to get down to the language model to actually do the tokenizing to actually then get the next word and do
Like
things?
natural language processing, things like that. Yeah, it's
Yeah,
interesting. So it's a big concern that there are going to be biases, or that
absolutely.
hallucinations. I know that's something that's been discussed with respect to large language models. If you don't find a way to damper the model or train it against fact-based knowledge, or do something to ground it, I think RAG is a technique for that. Whether it's a chatbot or some other type of application, you run the risk of having lots of incorrect or kind of irrelevant answers that it spits out.
Well, think about it. And that's what this paper talked about. It takes a lot of money, a lot of power, a lot of water, a lot of data. It takes cleaning the data, which is very human intensive, right? You've got to tag all of the data. So, for example, this was what Tony and I did at our last presentation at VMworld. One example is you can train these large language models to tell you the difference. Is this a picture of a cat or is this a picture of a dog? And the way you do that is you train it and you show it lots and lots and lots and lots of pictures of a
That
dog,
was the classic
lots and
problem
lots of
for
pictures of the cat,
decades, right?
and then it can figure out, based on the model, based on the pictures, which they digitize that, and that's all in all of those math, those arithmetic problems. They
Thank
they
you.
have all of the places on the picture, and you can tell this is going to make it a cat, this is make it a
Facial
dog.
recognition type
Yeah,
technologies, like with my phone, it knows if I have a contact, and it starts knowing who your people are. Like, oh, this
yeah.
is a picture of your wife. This is a picture of your mother-in-law.
This was an
This is
immense
your
problem
dog.
for decades that they
Yeah, it
couldn't
learns
get
over
past. And
time, even
this
with
goes back to
phones.
the Jetsons question, right? And when the Jetsons in a cartoon in the 60s had a a a a housekeeper, and the
Yeah, that
housekeeper,
maid. She looked like
and
a
the question
toaster.
was,
Yeah.
what was going to happen first in the 60s? Are you going to have a simple task being performed, such as a housekeeper taking care of a house, or will you have the computer beat the world's greatest chess player? And the truth is, everybody got it wrong. Literally everybody. The housekeeping effort was much, much more complicated than this, than playing chess. And Garry Kasparov got beat by Watson in the late 80s, I think, or early 90s. And for the most part, we're just getting to a point, and this is the beauty of all this, right? What you're talking about, Gina, of
Right.
being able to recognize these different, very complicated, the Google dog problem, I think it was called for a long time, right?
Well,
But I
we have
think
the
it's
robot dogs now too.
those are
We are
scary.
getting closer to the housekeeper. They have those robots you see on
Yes,
occasion.
we are. We
I
are.
don't like them.
We are.
I don't like
Scary.
them.
Hey,
It's
look, I was
very,
in
very
Vegas this
scary.
weekend, and I saw real. I have pictures of them, driverless Ubers.
They have them
I,
here.
Oh, like
I
Waymo?
really was. I've never seen
I don't
one
like
before,
Waymo
and it
and
really
Uber.
was there. It had no driver in it, and I was standing right next to it. And I'm like, oh my gosh, that really doesn't have a driver in it. And
Did
then
you
I
get in?
talked to the Uber driver. I'm like, you guys realize you're competing against ghosts? They didn't even know. I didn't speak
Not
English anyway.
ghosts,
But
AI,
yeah.
robots, machine learning.
Ghost in the
But yeah,
machine.
they've got Waymos all over San Fran when we were out there in the fall. Like
Well, they are.
we didn't
They
take one,
are.
but they're
Did they have
around.
no drivers? I mean, they
They
have
have no
in
drivers. The problem
California.
is if somebody puts a
You have to have a
cone or
driver.
touches it, it stops. You can fool it in certain instances.
Yeah, but I think now a few cities, but at first it was Pittsburgh. It was the only place that would allow
Austin.
actually. I think it was maybe, but I mean, I know it was in Pittsburgh that at Carnegie Mellon that you were allowed to have actual cars moving around. Maybe Austin too, but not California, not in Vegas, not for a long time. Now it is. That's all. So we digress here quite a bit. But Gina, let me draw us back onto some of this actual subject from a historical perspective. 70 years ago, when artificial intelligence was first introduced, there was a language called Lisp. It's an acronym, obviously. I don't even remember what it was. And there was ideas of it. And then, of course, it went in the back burner for over 50 years. And then it came back when the processing came back. But what other steps do you think actually happened from both a sociological perspective as well as the obvious perspective of the processing power and the ubiquitousness of data everywhere? What else really happened to lead us along these lines? It really happened at the beginning of COVID, right? But what else do you think happened?
It was definitely the transformers. It was definitely the architectures, and having the ability to, having GPUs or graphic processing units that could interact with the CPUs on a computer and take the data in and run it fast enough on those GPUs, with all of the different algorithms
And they came from
running.
games, right? They came
Huh?
from gaming. The
Yeah,
GPUs came
because
from gaming.
yeah. So what happened was they wanted to have beautiful images when you're gaming. So that's where the GPUs came from, and they used them for virtual desktops and things too. And then all it was running the math behind getting the images up there. And somebody was like, "Dang, that's the stuff we're trying to do with machine learning and deep learning. We just have math problems. I wonder if it would work." And it did. And even though they wouldn't let us talk about servers for a long time, NVIDIA finally got on the ball and said, "Hey, you can actually do compute with these things." And um, that's how they ran with
I
it.
think it
And
was the
then I think,
government, of course, right, that
well,
learned that they had tremendous power and started buying them or something. That's legend maybe, but that's kind of what I understood around 2018, 2019 when we went to so many other conferences that we go to and they could create the Van Gogh paintings of us and all.
Yeah,
That was
that was
absolutely
pretty cool.
amazing. And they could do it instantly. Well, let me ask you this question as well. So the public applications that we know of, and now DeepSeek, but ChatGPT most foremost among them, and Grok, of course, now, and Gemini and others, they all are more focused right now on what's referred to as generative AI, and you've talked about that a little bit. My particular interest, as I kind of alluded to before, is something called predictive AI. In other words, the ability to determine things like data, certain amounts of data is more important than other amounts of data. I mean, come on, let's get right down to it. Being able to predict the stock market or predict when the actual weather and so on.
Weather's a good one.
Yeah. The stock market is too. We'll get rich, right? But or I can predict, what the New York Yankees are actually going to do when they screw up on the next selection for third base, which they're in the process of doing at the moment. So what what do you think? What about predictive AI?
Yeah, you want that Back to the Future too, when Biff took the sports.
I actually want to go
back.
back. I want Elon to develop a time machine and go back to the 9th inning of the first game of the World Series and put in Tim Hill instead of Nestor Cortez. That would make my life better. Okay,
dude. If Elon
digress.
invented the time machine, you would come out and your parts would all be in different places.
Well, they did that on Star Trek once too. I think with the transform. But tell me, what about predictive AI? We're having a lot of fun here, which we should on the Don Sullivan Show. But what do you think about predictive AI? Why is that so far behind?
Behind? What'd you say? Why is it so what?
Why is it so far behind generative AI?
I don't think it is. I think the generative AI gets all of the attention.
Oh,
right?
Okay.
I think generative AI is I'll give it to OpenAI. They were smart enough to put a chatbot in front of it and make it free so anybody could try it.
And OpenAI is ChatGPT, correct?
That's ChatGPT, right? And so that was brilliant because they got all the attention on them. There's actually, I use an AI platform called Jasper, which is specifically trained to do a lot of marketing things. It's got a nice workflow. I mean, of course, my company is so small, we don't take advantage of all the really good.
Not small to me. Love
has,
digital
right?
sunshine.
But that's how ChatGPT got its foothold, is it put it in the hands of people, and everybody was like, holy crap, look what it can do. And then people forgot about, like, why is it doing it? Why are we doing this? You've got so much crap now on the internet. You've got Google with whatever they're calling Bard now. They call it something different.
Gemini?
Is it Gemini? That's right. That's right.
Yeah.
That's right. So you've got them taking over the search page, so it's all AI, and half the time it's wrong. Right. So,
well, I think it upsets websites and publishers too, because if people are just getting that summary at the top
the first screen
and not scrolling down, they're not getting a click. They're
I don't know how it works in their advertising model.
They're not going towards first sources either.
No,
which we
not
were
at
always
all.
trained to in school.
They don't, and that's like how we were trained. That's what I get worried that kids aren't trained, because, like, okay, let's stay on both of these, because I also think the predictive is important in this too, right? So if you don't know how to read your sources, you don't know how to ask the questions to figure out where the sources are. Some, like, right now, at least Google search will give you the source it based its answer on. And that's getting more and more prevalent with the models as they change, and they're asking the models to show their work, so to say, as they go. But you have to be able to actually go back and check the work of this model, because all this model is a parrot. It's been trained to predict what the next word's going to be. It's been trained to parrot words back. It's not trained to think for you. It can give you a head start, but if you look at it, a great example is all right, I'm just totally gonna have a brain fart here. DeepSeek. The whole buzz around that was, oh my God, they're so much cheaper. They probably really aren't.
That's
but they
right.
did have some,
I agree. It's garbage.
I heard they did spend a lot of money.
Yeah, wait till we see the actual workload, and wait till we see the actual algorithms that they're using and how they actually train their model and all those things, which we don't know yet.
Well, there is some people that are playing with it. I'm not going to play with that model personally, but the people that are playing with it have asked it questions like, what happened at Tiananmen Square?
Oh yeah,
And it
yeah.
won't
I
Oh
answer.
see
yeah,
that.
won't
What happened a
answer.
couple of years ago in Hong Kong? Won't answer it. The reason why is because that company is based in China. They are beholden to the laws in China. They don't talk about that in China. So that's how it was trained. So we are getting, and that's not to say that OpenAI did any better. OpenAI, this is one of the point. I love this paper a lot. I'm gonna keep going back to it. One of the points in that paper and about the bias is true. I mean, I'm the weirdo that's been a blogger for a couple of decades,
Long time.
a long time. But
How
I'm
can
and
you're only 29 years old? How could you be blogging for 30 years? I don't know how that works, but
I don't
maybe
know.
it's a time machine again.
Not Elon, but but I'm the outlier because I'm a woman, and I have learned to write very. I've learned to write very professionally, which doesn't. If any kind of test I've ever taken to say, are you a man or a woman when you write online? Show us what you write. Never come back as a woman.
That's
Right.
interesting.
Yeah,
So,
that is
That
interesting.
but
is
that's
very interesting.
predictive. That's predictive stuff. That predictive stuff. That's kind of like analytical
Yeah.
things, just matching, pattern
Yeah.
matching to things, right? So, which that's what it is because most of the people that write like me are men.
Do
So,
women and men write differently in general? Have
I
they done
never would have
studies
thought that.
where? Yeah,
Not
it never
you.
occurred to me.
according to these analyzers, yes, which is
That's
they use
interesting.
some kind of analytic thing, but that's the kind of thing. If you scrape the internet for all the writings in the world, most of that's going to be written by men, which can be bad, can be good. Like one of the examples the paper gives is if everything on the internet says that when they refer to doctors, it's he, him, that kind of thing. And then you go back and you ask a question from that model, can the doctor be a woman? No, because everything I read and everything you gave me to train on said he and him. So I think it's all men. So that's like a very simple, high level
Yeah,
kind of
biases.
bias that can happen.
My
Look at
gastro
Donald.
lady wouldn't like that.
No, she probably wouldn't, right? But that's kind of the biases, and that there was nobody to check for them because they're really not. That's not the kind of checks they have. The checks they have are, and they do. This is the other thing, to think that these large language models are trained by themselves and it's all automatic and it's all in the machine. It's not. So once they get the model trained and it's in use, they also have people on the back end, usually people with master's degrees in English that they're paying $20 an hour. They have them um, looking at some of the outputs of AI and of different automated things that are being driven by AI and fact checking them. And you can imagine right now how much fact checking needs to happen, right? Because people are saying some true stuff and people are saying some false stuff and people are being crazy and shady and people are being crazy and losing their minds over stuff, right? So
Or
like
the
what
stuff
is
that's
really the
just
truth?
coming out as blather.
Yeah,
Right.
well, it's been fact checking's been pretty controversial lately as well. I know Mark
Yeah.
Zuckerberg says they're going to change to more of a community notes policy, I think, on Meta, but there's been
But
a
I
lot of
think you're talking
arguments.
even beyond that, though, right? You're talking about just as I just said, just the blather that can come out that makes no sense at all.
Right. And so like
Because
if even that, like you have to be able to fact check it, right? So like there's all sorts of even think about a sports game. So if you're in the middle of a really hot contested Yankees and Red Sox game, right?
there you go.
Um
Now I'm listening.
so like and you are down to the ninth inning and it's tied up, right? And they're in New York. Like, what's gonna happen? Of course the Red Sox are gonna hit a home run last minute. You guys are out of
Oh
it.
Who's
boy. Oh
And
pitching?
hold
boy.
you,
Who's
strike you all
pitching?
out.
No, who's pitching? What year is it? Come on, you need more information.
Do you see what I'm saying? So
Yes, I
you need
definitely do.
somebody. You need somebody real time, because if the model gets confused, because the model's just going to go by what it thinks it ought to be, not necessarily what it is. You need a human on this end for now. They haven't figured out another way to do this, to put the right information in and say, no, don't push that to live. Let me check it. And you check, and you have to do all the things a human would do, right? Look at different places on the internet, maybe listen to the radio, whatever. And then fact check it and say, oh, no, that's right. Red Sox win. Woo!
Yeah, you know what, the output in general, when you ask it
No
to write
comment.
things for you, I still think the
And that's
output kind
rare.
of sounds like a young kid's book report, where they don't fully understand they don't understand the concepts, but
Just faster.
they've grabbed enough out of
Don't
their
wait till last minute.
textbooks
Well, I'm not sure if I would say that, right? It's more on the it's higher than that, because I don't want to give the impression that generative AI LLMs that that is not good, because there's so much good that can be done. For
Oh no, they're
example,
awesome. They're
but
impressive.
it has to be checked, and there has to be safeguards. Which is, you mentioned RAG before. That's part of the reason, right? Because like, if you go and train the model, by the time you get it ready to release it, that information that you've used to train it with is probably 6 months, 9 months, years old, not 9 months, 9 months old at this point, right? RAG is, and it's very general. If the inputs of the general internet, and right now DeepSeek is a great example. One of the reasons DeepSeek was able to go so fast and use less GPUs is because it used all synthetic data from its parent company, and also to
from every other AI company.
Yeah, they used all of this, right? So it's all synthetic data. So it's like kind of like the snake eating its tail, right? Like it's going round and round and round. So
It's a great
what you can
analogy.
do,
I like that.
right? So thank you. So what you can do, and what you should this is what companies are doing, enterprises are doing. RAG is just retrieval augmented generation or something. I can't remember what the G is,
Yeah, I think it's
but
retrieval augmented generation.
I think so too. And what it is you have your documents. And Don, remember when generative AI first started taking out, I was saying, can you imagine having this for a launch and having a model that's trained on all of the content I have to put out, right? I have to have my data sheet look a certain way. I have to have a solution sheet look the same way. I've got to have a blog post. I've got to have this technical thing. I've got to have the web page. I have new LinkedIn. Like, I have to have all of the new images. I have to have all this going. What if I was able to um, train a model on, this is all the new content from engineering. Here's the docs, my messaging doc that I have. Let's all train it on that, and then say run launch 1.0, and it'll spit out all the content I need. And then all I have to do is check it. I don't have to spend hours and hours. And if one little thing changes, oh, that feature didn't make the release, you go back in and you change your document, you retrain it, the model on it, and then you can run the query again.
So
That's
you
kind of what
actually
RAG
said
is.
something like this in your last presentation, I think, at VMworld.
It would be so cool to have something like that. And that's what RAG is. RAG is like, here's my information. This is current. This large language model knows how to write content. It needs to know this, and know how to do this. The first thing I'm going to train it on is all my templates. Let's let it do that, right? Great, we're good to go. And then every time that my information changes, because my product's constantly changing and has new features and everything else, retrain it through the RAG, and there we go. So you have to keep, that's a way to put some guardrails on what the large language model is. Large language model is great for doing things that humans can't get through. And I was going to give the example of, my friend runs an AI startup in Austin called, oh no, I'm not going to, I'm going to tell you, it's a health startup, so I'll remember it in a minute. Autonomize AI. It's pretty cool. But what they're trying to do is help with the insurance part of things, because they have doctors that actually look at all the notes that other doctors write when
Let's get
they're
him
trying
on.
to get right.
Introduce him to me. Let's get him on the Don Sullivan show.
Oh, I
there,
totally
Gina.
will. He'd love to come.
That'd be a
He's
great
really
guest.
good on podcasts too. But the reason, so I want to kind of leave with a good example, because I do think I've used them all the time, so I think that there are good things. They basically are taking all of those notes and they read through them, and they you have to have him on to explain exactly how, but they crunch through all the notes so that the doctors that are there doing the analysis of what the doctors are requesting medicine or procedures for the insurance companies, they don't have to sit, for one patient going through and comparing to what they have, what medicines are they taking? Is this the right approach? Blah, blah, blah. They have it all synthesized for them, and they're able to go back and see everything if they have questions, and there's guardrails to protect HIPAA safety and just patient safety. So it's not all given over to a machine, which is what
That's
this
amazing.
is.
It's
It's really,
amazing.
really, really cool.
Gina, is that basically extractive AI that they're using, where they're getting the information out, citing it, and kind of providing a summary of sorts? Or I'm just curious.
It's still generative AI, but it does extraction. So I don't know if there's a different, if there's something different. I don't know.
It's maybe a subset. I haven't heard that term either, Steve, but that certainly is a good one, which you can now coin.
No, I think there are other people that roll with that, but I am not an expert.
All right. Well, that's one I haven't heard before. Hey, Gina, we've got about 10 minutes here, and there's a couple of other questions that I really want to get to. This is a lot of fun, and this is really interesting. We're going to have you back probably many times on the Don Sullivan Show. But I would like to discuss something a little bit more mundane, just from a generic, non-technical user, not necessarily even a teenager, but the doctor who is just wanting to use this new tool that you just referred to, who we would love to have on to talk about it. But how does one get started, and how does one actually use this, other than the obvious of just what we're talking about, just running a Google search and getting some type of answer that you pay too much attention on, or you give too much relevance to without looking below, or something else that is a little bit more sophisticated, to really wanting to write a term paper that isn't just a copy of something. It doesn't get into copyright violations, which we know there'll be lots of court cases in the future on, and so on. How does somebody really use this?
So the first thing you need to think about is security, right? And you might not think so, but you should, because you can there's AI bots everywhere. They're in every operating system. They're in, every platform that you use to create data on. So you want to, if you're going to use the Google version, or if you're going to I use Office 360, or Microsoft's Copilot, which is a derivative of ChatGPT, obviously. You want to make sure that you're paying for use, because in most cases, and read the fine print, in most cases, if you're paying for use, they won't use the data you're inputting to retrain the model, because there's no way to say that model won't be jailbroken. And I don't know what you're doing, but I don't want people knowing the stupid stuff I ask. So,
Yeah, right.
that this protects you. So that'd be number one. But the way they work is, the large language model, you're never going to touch that. You're never really going to see that, but you have to create prompts, or basically you type and ask a question. And people have different theories. I definitely don't like saying please and thank you. Although if you look at the Microsoft training, it says that it makes it more effective. I'm not really sure about it, but I think it's a
Why?
robot.
It needs to
You
be
hurt the
polite.
robot's feelings.
Yeah.
You could hurt the LLM's feelings. You need to be polite. I don't
Huh.
do, but
Danger,
that
Will
might have,
Robinson. You've insulted me.
that's what happened with Hal, isn't it? I'm just saying.
It is what happened.
If
You're
they
right.
take
That is
over,
what
we're
happened.
gonna have
Hal.
to. Maybe we
Arthur
should be
C.
polite.
Clarke is rolling in his grave and laughing. But go ahead.
We're gonna have to put the charm offensive on Don if we have robot
we don't do that in
overlords.
Jersey typically, but yeah, I think we might here soon. I digress, Gina. Please continue.
Okay. Now I'm thinking of you guys just really talking to the model, saying, listen.
That's what we do in a Don Sullivan Show. We make this memorable. But go
We
ahead,
should bring
please.
a model on. Yeah, bring a robot on. Yeah, for you to ask questions.
There you go. You should do that one. That'd be awesome. We should do
That's
it.
right.
Just do
We
prompts.
should, Steve.
We
We
should
will
do
have
it.
an interview with a robot.
We
That's
should do
right. We
it.
will have a guest.
That'd
We
be
will
so cool.
absolutely
We should
do that.
totally do it. But that's basically what it is. So I could give you an example. I am looking, and Don, I don't know if I told you this or not, but I am looking to go back into, there's so much going on with AI in big enterprises. I'm looking to go back.
I know.
And
you have told me. I know.
yeah.
So am I. On some level.
Cool. But I'm using, I use OpenAI. I use not OpenAI. I use Copilot a lot. So the thing is, to interact with my own content, you have to upload it to their cloud, which is fine because I use Office 365 all the time. And I'll do things like I had a screening call today with a recruiter. And so I said, here's the resume we used. This is the job description. I'm telling this to the prompt for Copilot. Okay, now you are a recruiter and you're going to talk to me for 15 minutes and screen me to see if I'm okay to interview for this job. Ask me questions. And it actually does a pretty good job. In most cases, it's at least asked me one question that the interviewer asked me. And with me, I'm a very tactile type of person to remember things with. So if I write it and I type it, I'll remember it better. So it asked me questions about my resume that relate to the job description, because that's the parameters I told it to do. Don't go with the whole wide internet. Use these two documents. We're going to work on this. But because it's been trained to do that, it's been trained to ask interview questions, work on job descriptions, know how to pull that information out. It does a pretty good job. So that's kind of how I use it. You can use it to write things. You need to be really careful. I kind of fell into this trap too. Like, let me just write stuff with this. It doesn't sound like me. I have a very distinct voice when I write. It doesn't sound like me, and it uses. There's like a list of words that are very. I have to find it and send it to you.
Comes
Like
across
very.
kind of stilted or bland or generic.
This is
It's
yeah, and
it's
it uses
missing
words,
something. Yeah.
but it uses words nobody says. So
Yeah, that too.
what I do like it
I've
for
been told
writing.
not to do that.
Yeah, what I use it for writing is I'll write it to where I think it's good, and then I'll say, all right, look at this blog post. Does it seem cohesive? Is there places I could tie it together tighter? And do you like the order? And sometimes, a couple of times it's come back and it's like a very different order, and I try it and I'm like, oh yeah, that flows much better. Half the time I'm like, I'm not saying that, whatever, it's
Yeah,
good.
I,
Yeah,
I
but it's a
think that
good
would be the
checker.
case with me too. I write very distinctly. I intentionally use run-on sentences to increase my intensity. I do. I got in
You
trouble in the
make up
'70s in
words
grade
on
school.
occasion.
I what?
You like to
I
make up your
do.
own
I've
Yeah,
made
words.
the
up
truth's coming
flarity.
out.
That's my word. Clarity with a flair. Yes, I do make up words, and I do that on purpose. And I'm sure that I will have many conflicts with the various different applications in the future.
But that's the thing is you shouldn't view this as the authority on how to do things. This is the authority
Yes,
on.
that's
It's not even the authority. This is the
The
probability.
sidekick.
it's a
It's
probability.
a little
It's
helper.
a mathematical iteration, is what it is.
Right. Example. That's actually really good. That's exactly what it is. So this is what probably could be. But then if you look at it and be like, that sounds dumb. I ain't talking like that. Then you fix
Then
it the way you
don't.
want it to
Then
talk.
you're talking. And so, Gina, this is a perfect segue. We've only got a few minutes here to go. But this is a perfect segue. And I have an example for this, which will be kind of humorous. But what do you think the biggest dangers of the present state of AI are?
I think the hype is one of the biggest dangers because we're not thinking about what AI can. We as a community of technologists, we're not thinking about what the future can be, and thinking of this about this as computer scientists and technologists. This is, I really do believe, the next phase of computing. We need to get rid of the hype. We need to quit listening to people that want us to get to AGI. There's so much good that can be done.
AGI, say it again.
Uh,
What's AGI?
no, general intelligence,
Agent something. Artificial
general
general intelligence. That's
intelligence,
right. It's the
right?
super
Where the robots are
intelligence that
smarter than
Sam
us.
was talking about.
Don't think about that because it's so far away. We don't have the power.
And the architectures, the framework.
The
Agentic
architecture.
AI, stuff like
Yeah,
that.
agentic.
No,
Yeah.
agentic AI is now, and I
As
have
a
my
framework,
maybe.
as a approach, right?
Well, agentic AI is just, it's not just bots, but it's kind of like,
It's
I
agents,
don't
right?
have the words for it yet, but like it's that is available now. That's what people are working on now, and that is
Am I right
available
though?
to
It's the
happen.
agent architecture, and that's at
Right,
least
right.
how they. Yeah, okay.
Yeah, and that's fine. But let's talk about it as, what can this do for us, instead of like, this is going to wipe out all the people and we can just pay robots to do it and we don't need people to pay anymore.
So
No,
Elon's too afraid. He's watched too many science fiction movies and that kind of thing.
I'm not going to say what came into my head, but yeah.
Okay, that's probably a good idea. With Don Sullivan show might be over before the first few weeks. But go ahead.
But like, that's number one. But number two, and we're engineers, we should be able to solve this, is the problem with the environment, right? So like, to run these GPUs and the multiple iterations of them in a data center requires so much power and so much cooling. So it requires a lot of water to do the cooling. If you'll notice where they're putting the great big, the new super big data centers, they're in rural areas in the South that are close
East
to
of
water.
Austin, east of San Antonio, right?
Well, that's and then the new ones are going east of Dallas, up north of Base.
Well, one thing, and I'll add to you with this, that this is one of the few times in human history, time of Newton is a different one, that the mathematics actually did not precede the technology by about 100 years. In the case of Newton, Newton and Leibniz had to discover calculus, Newton in particular, to actually prove the Principia. And so the math and the technology, Newton's laws of mechanics at the time, became on the same plane or same time frame. Now we're in a situation, and we don't know what's going on in the bottom and the basements of math departments in all the universities in the world, but the algorithms just are not good enough at the moment to keep up with the technology. That's why it is, as I flippantly state, for the most part, mathematic iteration. At some point, that problem hopefully can be addressed with better arithmetic, better actual math
Right.
algorithms that are on top of it to make it much more efficient. That's what supposedly DeepSeek had done, and we know that really
I think that
didn't happen. But it,
well, let's give them their due. I think they did do some really clever engineering to
we'll
get
see
to the
when
place.
they
So,
publish it. Yeah.
no, for that, I think that they do deserve a little credit for that. And it can be tightened up. And that's kind of what engineering is all about. You see somebody do something, you tighten it up. And at least they were doing something to address that challenge, because we don't have the power, we don't have the water to do this. As we can't
Not in
just
Texas, you
Sustainability
know.
issue.
Yeah.
yeah, because if you think about it, if you're heating up and you're cooling it down, that heat dissipates someplace. So they've set this down
You
in
have stadium-sized
north.
computers, so
Right. We're setting these in North Texas and in Louisiana, and that's going to go up, and they're going to run this during the summer in
That's
July
a
and
hot place
August.
anyway.
So like, what is that going to do,
think about
to
the
the
birds
environment
going
there?
above it. Oh my gosh.
Well, I think they'll be smart enough to go around, honestly.
Maybe not
But,
the
but,
first
but
10,000 or so, but
that's probably the next thing I have. Um, the other things I think, are just in general as a society, we need to watch what comes from this, because algorithmic harm is a real thing. Because if you give, it's all about the data. If you put the data from the last 100 years and train a model on, okay, let's figure out real estate. But for the last 100 years, a large part of that was redlined. So minorities weren't allowed to own houses, they weren't allowed to have things. So that's the data that's getting in there. So if you're putting some guardrails on that and working around that with clever math and clever algorithm, perfect. But you can't just take the data on face value and stick it in there and think that is representative of how our neighborhoods and our society, how we want them to work today. So we have to be careful about what outputs from these models, because we're not really sure what the inputs are. So we got to take everything with a grain of salt and drive it back down to the beginnings.
do you think, and I'll ask this last question and then we gotta be done here, Gina, as much fun as this
Oh,
all is, can we trust videos and pictures anymore? I'll
geez,
give you an
Don,
example. There's a very, very famous moment in the 1955 World Series where Yogi Berra slides in, or excuse me, Jackie Robinson slides in. It's called safe. Yogi Berra said to his dying day that he was out, and it's hilarious because it's 70 years ago. But I think he was out, and I've watched it thousands of times. And my father, who basically saw it live, thinks he was out. And now all of a sudden, in the last 5 years, there's a new angle on that video, which was taken by television cameras in 1955, and it makes it look like Jackie was safe. And from the other angle, the original one, it doesn't. And so I don't believe it. I don't believe it's real. And
It's
I
like the
might be
baseball
wrong.
Zapruder film. This is
Yes, it
interesting,
is.
Don.
It is a baseball Sabruta film. And so I just don't believe it. Now, is that me being ridiculously cynical? Probably, or ridiculously paranoid, or just totally biased about the Yankees? All the above are probably true.
Or are you concerned that it was AI generated? Is
Well, I am. I am.
Yeah, like the
And
deep fake stuff. I mean, a
yeah, I
lot of
am.
those images are kind of obvious. I mean, didn't the royal family, they had an image that was kind of touched up with AI, but it got the fingers
Yep,
all
they did.
wrong. They get
Well,
certain
and I'm
things
looking at
wrong.
this video as somebody holding a TV camera in 1955 with absolute perfect clarity while this play is going on, and they're standing in the third base stands, and it was totally level. I just don't believe it. Now, again, I have no evidence for that one way or another, and
well,
I haven't
you
seen it
can't be
other
the
than
only person
yeah,
that you can't be the only person that thinks that, because for me,
I'm
I think
not.
that's a very valid suspicion. And yeah, no, I think you have to. I even think before we had AI and Photoshop, you had to
Hmm.
question things that you see.
So for juries, for evidence, for media, it's just
You
we have to be
trust but
suspicious, don't
verify.
we?
Yeah, but we should have always. That's
Trust but
literacy.
verify, Gina. Right to my heart. You just quoted Ronald Reagan. I am so happy. But I digress. And
But no, look, that's like a big thing with me is literacy and media literacy. You have to be able to verify, and if it doesn't make sense to you, yeah, I think it's important that we recognize our own biases. But like, if it just doesn't make sense from a logical viewpoint, yeah, I think that that's something telling you that you're probably right. But how do you prove it? But like, we have to be that way. We can't believe everything somebody puts in front of us. Not in this day and age at all.
And with
Yeah,
that,
I'd agree.
Gina Rosenthal, I am incredibly grateful for you to have appeared here on the Don Sullivan Show as one of our first guests. And we're going to have to close out now. We're over time, but this was absolutely wonderful. Lots of fun. One of the beauties of the Don Sullivan Show is we can go as long as I damn well want to.
Woo!
And we have in this case. So, want to say goodbye, Steve?
Thanks, everyone. Thanks for coming, Gina.
Thanks
All
for
right.
having
And
me.
finally, thank you, Gina. And we'll have you on again about other subjects. We're probably going to have you on a lot. And I will say thank you, everyone, for listening. And please tune in and download again. And remember, folks, all at bats are situational.